Okay, students, we're continuing with vectors. So, a important fact of vectors is that where the vector is doesn't matter. In other words, if I draw a vector here, like so, okay, I've drawn a vector. But if I move the vector to here, it's still the same vector. And if it's here, it's still the same vector. So the vectors R1 and R2 here in the notes are the same thing. Um, Now, technically, when you take an exam and I ask you, show me the vector, you could put the vector anywhere. But some locations maybe make a little more sense than other locations. So it's not completely random where you put the vectors, but technically you can put a vector anywhere and it doesn't change what it stands for. Okay, the next topic we're going to look at is finding the resultant. Now that term kind of means the opposite of decomposing or finding the components, taking apart a vector. Here you're putting vectors together. In other words, you're adding. However, the components of a vector have to be at 90 degrees, but here we're adding vectors which can be any vectors. They don't have to be at 90 degrees. I'm going to show you three different methods. And the reason I'm doing the three different methods is because they all lend themselves to different aspects of the physics. They all accomplish the same thing. They're all adding vectors, but the emphasis, the way it looks, is going to be a little different. So my first method is the nose to tail method. That's my personal terminology. It's not official physics language. So, so here we have a vector A and a vector B. And we're going to arrange them so that they are nose to tail. So let's see, actually I can show you what I mean. If I draw vector B here like this, and I move it so that its tail is on the nose of A. There. Okay, now what you end up with is basically this arrangement, right? You've got the two vectors on each other. Now, the next step in this process is to draw a new vector from the tail of A to the nose, the tip of B. So you're drawing it, it's going to end up looking like this. So here's the tail, here's A, you're going from the tail of A to the tip of B. Or I could have done it up here. I could show you right here. So here I'm drawing the answer. It's from the tail of A to the nose of B. There you go. That's the answer. So that's the first method for adding two vectors together. I should point out that whether you put the tail of B on the nose of A, or you do it the other way around. You put the tail of A on the nose of B, you get the same answer, right? It doesn't matter which way you do it. So don't worry about that. Okay, let's move on. Here comes the second method. So this one, a famous physics teacher called Hewitt called this the parallelogram method. And so that's maybe a real name. And I call it the tail-to-tail method. So we're still doing the same two vectors, A and B, same as before. And what you do is you move them so that they are tail-to-tail. So let's say I have a vector right here, and I could move it so that its tail is, Okay, so I moved B so that its tail is on A. And so what you end up with is this arrangement, right? The two vectors are tail to tail. The next step is to draw reference lines. But my students have trouble with this. I know that. These reference lines have to be parallel to the original vectors. So let's see if I can do this. I'm going to draw a line parallel to B, but it has to go through the tip of A. So I'm drawing a reference line here. And I also have to draw another reference line. It's got to be parallel to A and go through the tip of B. And so it goes like that. And when I'm teaching this in person, what I like to do is I like to have a ruler and I put it on top of, let's say, the A vector, and then without turning it, right? Turning is a no-no. You want to keep it at the same angle. You just slide it up until it gets to the tip of B. And you do the same thing for the other one. You put the ruler on top of B and you slide it over so it's on the tip of A, and then you draw. Okay. So now what? Our answer is then going to be from where the two tails are touching, the two vector tails are touching, to the intersection of the two reference lines. So here it is in my notes, and I could draw it again. I can do it here. Let's just go and I'll draw the answer. It goes from where the two tails are together to right there. Boom. That's my answer. So we have drawn the sum of vectors A and B. This is also known as the resultant of A and B. Okay. So now we are going to have one more method. Important point here. Many of my students make the mistake of drawing the answer too long, like they'll do this. I take points off for that. That is wrong. Don't do that. You want the vector to go, yeah, like, and stop right at that intersection. And then you can put your barbs on the arrowhead. Okay, don't go too long. I take points off of that because it's wrong. You want it to be just the right length. Okay. The third method is it's more mathematical, and it's the way vectors are handled in video games and computer simulations, and it's a more general way to get it done. Okay, so the first step, we have the same example vectors, right? A is the same as before, B is the same as before. But what we're going to do now is decompose these two vectors into x and y components. So this A vector, if you decompose it, you can see that it's going to have a part that is like this to the right, and that's the x component, and then a y component. And so that's why you have this x component and this y component. The B vector, well, if you decompose it, it's going to have a x component like so, and a y component like so. And that's what I've drawn here. Right? And I was kind of careful when I made these notes. I made everything just the right length. Okay. Now that you've done that, you're going to add the x components together. So you take this x component and this x component, and you put them together. Here's this one, and put them together, and you add them up, right? So basically you're putting the tail of this one on the tip of that one, and you get the new the answer is X component. We'll call the answer the vector C. Here is the Y component of, let's use a different color. Here's the Y component of the first vector. Here is the Y component of the second vector. And here is, wait, no, that's wrong. Let's do it this way. Here we are. There's the Y component of A. Here is the Y component of B. Now we're going to add these up. Now, since they are in opposite directions, there is partial cancellation. You could think, to get the answer, one way to think about it is to say, I'm going to take my A vector, the Y component of the A vector, and move it up to here, like that. So it's the tail of A is on the tip of B. And then the answer is from the tail of B to the tip of A. So that's the answer. And that's basically what I've got right here. It's this piece. Okay, so now you've got the components. And now you put the components together. So here is the Y component, and here is the X component. You put them together, and you get the answer. Now, we're going to be doing a little more on this method. Here, it's all lengths, right? It's all geometric, but we're going to be transitioning to using numbers, right? So this could be, 20 millimeters of displacement, and this could be, 10 millimeters of displacement, and do it all with numbers. And that's really how computers and video games and so on handle vectors.